Ladies and gentlemen, I want you to take a moment and look at the car sitting in your driveway right now, or maybe glance at the brochure of the electric vehicle you're planning to buy this weekend. It looks modern, doesn't it? It has a giant touchscreen. It has sleek LED lights, and the salesperson probably told you that it represents the pinnacle of modern engineering. But I'm here to deliver a very uncomfortable truth. That vehicle is already a fossil. A massive accident has just happened inside the automotive industry, a catastrophic, industry-defining accident, but you won't see it on the evening news. There is no twisted metal scattered across a motorway. There is no smoke rising from the asphalt. There are no flashing blue lights. This is a technological crash, and the victims are the millions of electric vehicles currently sitting in showrooms across Europe and North America. Vehicles that, as of this morning, have suddenly become technologically obsolete. If you signed a finance contract for a generic 400-volt electric vehicle from a traditional manufacturer in the past year, you may have unknowingly purchased the automotive equivalent of a Betamax player in a Netflix world. For the past decade, we have been living in what future historians will probably call the beta testing era of electrification. We accepted mediocrity because we had no alternative. We accepted that lithium-ion batteries are heavy, unstable chemical systems that can ignite if punctured. We accepted that charging an electric car could take 40 minutes or more because outdated electrical architectures simply cannot handle high power without overheating. We tolerated laggy software, plastic interiors, and constant range anxiety. And somehow, we called this progress. But it wasn't progress. It was a placeholder. And now, the beta test is officially over. Through its premium Exceed and Exlantix divisions, Chery has not simply improved the electric car, it has triggered what can only be described as an extinction event for the current generation. While the world was busy arguing about trade tariffs and brand loyalty, Chery's engineers were quietly finalizing a group of technologies that make most modern EVs look like relics from the Nokia era. Today, we are going to conduct a forensic autopsy on the old world. We will examine the technologies Chery has built to dismantle the competition: the E0X high-performance platform, the Kunpeng solid-state battery, and the gigabit Ethernet digital architecture. This is not a car review. This is a warning about your investment. Welcome to the silent crash. To understand why companies like Volkswagen, Toyota, and even Tesla are suddenly facing a crisis, we need to strip the car down to its absolute core. We need to examine the bones. This is the E0X high-performance electric platform, internally known as the Mars architecture. Most traditional manufacturers are still playing a complicated game of automotive Tetris. They take chassis designs that were originally engineered for internal combustion engines, platforms filled with transmission tunnels, compromised crumple zones, and heavy steel floors, and then attempt to squeeze massive battery packs into them. Or they weld together hundreds of stamped steel components to build a flexible subframe. This is 20th century thinking applied to 21st century problems. Chery abandoned this approach entirely. The E0X platform uses integrated high-pressure die casting. Instead of welding 70 or 80 individual steel parts to form a rear chassis section, Chery casts the entire structure as one massive piece of aerospace-grade aluminum alloy under thousands of tons of pressure. Why does this matter to you as a driver? Because this isn't just about manufacturing cost, it's about physics. This method eliminates hundreds of structural weak points, the welds, and increases chassis torsional rigidity to more than 40,000 Newton-meters per degree. To put that into perspective, that level of stiffness would have belonged to a carbon fiber hypercar just a decade ago. A rigid chassis means suspension geometry remains mathematically precise during high-G cornering. It eliminates rattles and vibrations, and it provides superior structural protection during a side-impact collision. But this platform is more than just a skeleton. It is also an energy conduit. The E0X architecture runs on a native 800-volt electrical system, and this number is critically important. Most electric vehicles today still operate on 400 volts. The difference is similar to filling a swimming pool using a garden hose versus a fire hose. By doubling the voltage, the system can deliver the same power using half the current. Less current means dramatically less heat. Using advanced silicon carbide electronics, Chery has reduced energy losses in the inverter by nearly 50%. The result is charging performance that borders on absurd. We are talking about adding 150 kilometers of range in just 5 minutes. You could pull into a charging station, plug in the car, walk inside to buy a coffee, and by the time you return, the car already has enough energy for another 2 hours of motorway driving. If your next vehicle still relies on a 400-volt system, you are effectively buying yesterday's technology at tomorrow's price. Now we arrive at the heart of the machine, the battery. For the past 15 years, the entire automotive industry has been dependent on liquid lithium-ion chemistry. And we all know the problems: dendrites forming inside battery cells, thermal runaway events, and the unsettling reality that if a lithium cell is punctured during a crash, it can ignite into a self-sustaining fire that produces its own oxygen. For years, legacy manufacturers insisted that solid-state batteries were at least a decade away. They said the technology was impossible to mass produce. They said it remained science fiction. Chery disagreed. They unveiled the Kunpeng solid-state battery series. This technology alone could render the internal combustion engine permanently obsolete. By replacing the flammable liquid electrolyte with a solid ceramic or polymer separator, engineers achieved something previously considered impossible: energy density, safety, and speed. Let's examine the numbers. These new cells reach an astounding 600 watt-hours per kilogram. For comparison, the most advanced batteries used by Tesla or BYD typically range between 150 and 290 watt-hours per kilogram. In other words, Chery has nearly tripled the energy capacity within the same physical space. This translates to a theoretical driving range of 1,500 kilometers on a single charge. You could drive from London to Rome without stopping to recharge. You could cross entire states without even glancing at the battery gauge. But perhaps the most revolutionary benefit is safety. These batteries have been subjected to brutal stress tests. They have been cut open with saws, pierced with steel nails, even shot with bullets. The result? No fire, no smoke, no explosion. The chemical volatility that has haunted lithium batteries is effectively gone. Range anxiety and fire anxiety may soon become historical footnotes, concepts our grandchildren will struggle to understand. But even a strong body and a powerful battery are useless without an intelligent brain, and this is where the technological gap truly becomes obvious. Walk into a dealership today and inspect vehicles like the Volkswagen ID.4 or the Toyota BZ4X. Underneath the surface, many of these cars still rely on CAN bus communication systems, technology originally developed in the 1980s. It's essentially a network of copper wires transmitting slow electrical signals. It's outdated, slow, and incapable of handling modern data demands. That's why infotainment systems freeze, why voice assistants struggle, why software updates frequently fail. The E0X platform eliminates this bottleneck. Instead, it runs on a gigabit Ethernet architecture capable of transmitting data hundreds of times faster than traditional systems. The difference is like comparing dial-up internet to fiber optic broadband. This high-speed network powers a service-oriented architecture, allowing the vehicle's software to evolve continuously through updates. More importantly, it feeds data into dual NVIDIA Orin X processors, delivering over 500 trillion operations per second. This computing power processes information from LiDAR, radar, cameras, and sensors in real time. The car can detect a child running into the road and begin braking before your foot even touches the pedal. This is no longer just transportation, it is a mobile data center. Finally, we arrive at how all of this technology feels on the road. Chery calls it Flying Fish Chassis 2.0. Behind the poetic name lies brutal engineering sophistication. Because of the massive computing power we discussed earlier, the suspension system is not reactive. It is predictive. Using LiDAR and cameras, the vehicle scans the road surface ahead, building a three-dimensional map of potholes, bumps, and irregularities before the tires even reach them. The system then instantly adjusts electromagnetic dampers and dual-chamber air suspension to compensate. The wheels move violently to absorb imperfections, but inside the cabin, everything remains perfectly flat and composed. It is the magic carpet that methods of Mercedes-Benz spent decades attempting to perfect, now executed digitally. The system also includes rear-wheel steering. At low speeds, the rear wheels turn opposite to the front wheels, shrinking the turning radius of a 5-meter luxury sedan to that of a compact hatchback. At high speeds, they turn in the same direction to stabilize lane changes.